Paleomagnetism Busted. Let's look at a portion of a typical geology workbook. It begins by stating some minerals in igneous rocks develop a slight magnetism in alignment with Earth's magnetic field at the time of their formation. Also, scientists have discovered the polarity of Earth's magnetic field has periodically reversed, and the north magnetic pole becomes the south magnetic pole, while the south magnetic pole becomes the north magnetic pole. The workbook continues by saying, scientists have reconstructed Earth's magnetic polarity reversals over the past several million years. A generalized record of these polarity reversals is shown in Figure 10.4. The periods of normal polarity, when a compass needle would have pointed north like today, are shown in color and labeled A through F. Use Figure 10.4 to answer the questions. Yes, scientists have created a history of magnetic polarity reversals, assigning times to directions, but this history is based on a false premise and is completely wrong. The Earth's magnetic field has never reversed polarity once, let alone multiple times. The only reason for believing that the Earth's magnetic poles have swapped is the observation of alternately polarized bands of magnetic material. It has been incorrectly assumed that the reason for this is that the naturally magnetized minerals in lava align with the Earth's magnetic field when the lava is in the liquid state, and then remain frozen in that direction when the lava cools and hardens. Based on this mythical chronology, students are given tests like the ones in this workbook. Questions for Figure 10.4. 1. The magnetic field of Earth has had 3, 5, or 7 intervals of reversed polarity during the past 4 million years. Circle your answer. Number 2. Approximately how long ago did the current normal polarity begin? Blank years ago. 1.5 million years ago, a compass needle would have pointed to the north or south. Circle your answer. Number 3. The period of normal polarity, C, began 1, 2, or 3 million years ago. Circle your answer. 4. During the past 4 million years, each interval of reversed polarity has lasted more or less than 1 million years. Circle your answer. Students are led to believe that geochronology is true because it is on tests like these, and there are, quote, right, unquote, answers to the questions. But these answers are based on incorrect speculation and faulty assumptions. Science is based on experiments. Let's do some experiments with magnets to see what really happens. I ordered 50 tiny cylindrical magnets, axially polarized, from K&J Magnetics for $13 plus shipping. I would have liked to have used the cheap magnet buttons you can buy at Walmart, but you can't tell which is north and south on those magnets. The magnets came tightly packed in a small bag, arranged as 2 layers of 25 magnets, each layer consisting of 5 rows of 5 magnets. Unfortunately, you can't tell from looking at them which is the North Pole and which is the South Pole, so I used a sponge floating on a dish of water to find out.
To determine which is the North Pole of the magnet, we put the magnet on a little sponge and let it float on a dish of water, and no matter which way we turn it, it will always point back to north. This way is north. I know that from the map.
It is hard to hold such tiny magnets while painting them, so I stuck the south pole of each magnet to a steel vegetable can. Then I put a little bit of red fingernail polish on the north end of each magnet. It was easier said than done because the magnets are so small. Unfortunately, I didn't do a very neat job, but I marked them well enough to tell north from south. When the nail polish dried, I did these experiments.
Alright, now here's our experimental setup. On the right I have some Nature magazines representing Europe, because Nature is the most respected scientific journal published in Europe, in Great Britain. And on the left I have some science magazines representing America, because Science is the equivalent magazine published in the United States. And in between them I'm going to put a piece of blue paper towel to represent the Atlantic Ocean between them. Now let's zoom in some, and let's see what happens when I start dropping magnets in there. So here goes the first magnet, and the second magnet, the third one. Now notice that on the European side the north poles are pointing to the left, but on the American side that one magnet there is pointing to the right. Come on, get in there. All those on the European side, the red is to the left, and on the American side, red is to the right, and he decided to unfold himself there. So let's see what we can do there. Now we've got the red on the left and the red on the right here. Notice that they're lining up anti-parallel. Let's try to start a third row here. See what happens. Oops. Okay, now let's see what happens with this third row. Now the third row, the red is to the left, like the first row. Now we've turned the whole thing 90 degrees, so we're not going north-south anymore. Let's see what happens when we start dropping magnets this way. There's one, second one. Okay, now these three, the red is pointing to your left. Try and drop one on the side there. Oops. Still wants to line up. Okay, there, on the side, it's anti-parallel. Let me try to put one the wrong way. Okay. Well, it'll just keep swapping around. I want to line up opposite directions. First row, red points this way, then that way. Third row, fourth row. Magnets want to line up anti-parallel. Now, during the time of the experiment, the Earth's magnetic field did not swap polarity 4 times. That's because the Earth's magnetic field has nothing to do with the way magnetic dipoles line up. They want to line up anti-parallel because that's the lowest energy state. It has nothing to do with the direction of the Earth's magnetic field, even when I've got them going east-west instead of north-south.
I know it is hard to see these tiny magnets on the video, but I don't want you to take my word for it. I want you to do the experiment yourself. It makes a great science fair project. You will discover that occasionally magnets will branch off at 90 degrees if the valley isn't deep enough to constrain the magnets to be parallel. You can try to get them all to line up in the same direction, and you will find you can't do it. The magnets will always stick together in alternating bands, just like the alternating bands found in nature. The reason they form alternating bands in your experiment and in nature has to do with magnets seeking the lowest energy state, not reversals in the Earth's magnetic field. The myth that a chronology constructed from paleomagnetism is busted. Paleomagnetism can't be used to determine when rocks were formed, so it can't be used to calculate the rate of seafloor spreading or the age of fossils found between magnetized layers. Paleomagnetism busted.